trig derivatives. You've studied a couple of them, sine and cosine. Now it's time to do the rest. Let's get serious about derivatives for trigonometry. Okay, so we got the first two up there, and you need to memorize those. You're going to need to memorize all 6 of these. There are several rules that throughout the year, you will just keep memorizing them. That is sad. I know you can always look things up, but that's not the way the AP exam always sees it, unless, of course, we have a special COVID AP year, which I'm not counting on. I'm counting on nothing, really. But if you have these memorized, it's much easier to solve problems and work through them quickly. It will save you time, energy, and will allow you to do some more in-depth problem solving on later stuff. We're going to use the quotient rule to help us find these last 4 trig derivatives. Hopefully you will recognize this particular fashion, sine over cosine, as being the same as tangent. Yes, that's exactly the same. So we're going to use the quotient rule that you know, fig minus gif over g squared, and find the derivative for tangent. So we got our usual suspects up there. We found the derivatives of sine and cosine and plopped them in the correct spaces. The fact that you're subtracting a negative sine squared means plus sine squared. So now here's where it's really going to come down to remembering some of your trig identities. What is another way of writing cosine squared plus sine squared? For those of you in BC calculus, you will need to remember and use these Pythagorean identities. For those of you in AB, you will need them in the future if you take subsequent calc classes. So cosine squared plus sine squared is equal to 1. It's equal to 1. And 1 over cosine squared, there's a much nicer way of saying that. 1 over cosine is the same as secant. Since it is 1 over cosine squared, that derivative is secant squared. I would ask you to take just one moment. You're going to find something very interesting about the derivative of cotangent. Use that exact same method. Use the quotient rule to find the derivative of cotangent. So we take those normal old derivatives, we plug everything in. This time we're going to get negative sine squared plus cosine squared. That's negative 1 over sine squared. 1 over sine. 1 over sine. That's cosecant, isn't it? The derivative of cotangent is negative cosecant squared. Now, once again, you can prove any of these using the same things. For secant, you can write this as 1 over cosine and use the quotient rule. And for cosecant, you can, For secant, you can use 1 over cosine for your original function. And then use the quotient rule. Same thing for cosecant. That is 1 over sine. Here are the final versions of the 6 rules. This right here is how you would derive the derivative of secant. You'll notice you get sine over cosine squared, but for reasons unknown, we've decided instead of sine over cosine squared, we like to write that as tangent times secant. This is tangent times secant. Not sure why, it's just, the way it's commonly written, no big deal. A few things to note. Notice that for all 6 functions, all of the cos, cosine, cotangent, cosecant, are negative. They're always negative. Also, look at the interesting pairings that they have here. One of them is secant and tangent. The next one is cosecant. And wow, I wrote that wrong. Cotangent. Hello, everyone. Let's fix that real quick. Secant and cosecant, tangent and cotangent. Secant squared, cosecant squared. Cosine and sine. They work in opposites. The cos are negative. These are really easy to work with. I want you to memorize these rules. It's going to help you whether you have to have them memorized or not. That is your basic trig function rules.